6850. Burner efficiency of a hot air balloon decreases approximately what percent for each 1,000 feet above MSL? A. 4%. B. 8%. C. 15%. The correct answer is A. The burner efficiency of a hot air balloon decreases approximately 4% for each 1,000 feet above mean sea level MSL. As a hot air balloon ascends to higher altitudes, the air density decreases. The burner, which generates heat by burning fuel to heat the air inside the envelope, becomes less efficient in heating the lighter and less dense air. The decrease in air density at higher altitudes results in reduced oxygen supply for combustion, leading to incomplete fuel burning and lower heat output from the burner. This decrease in burner efficiency affects the overall heating of the air inside the envelope. The rate of decrease in burner efficiency is approximately 4% for every 1,000 feet of altitude gained above MSL. This means that as the balloon continues to climb, the burner becomes less effective at maintaining the required temperature differential to sustain flight. Hot air balloon pilots need to take into account this decrease in burner efficiency as they plan their flights and consider factors such as altitude, fuel consumption, and the ability to maintain the desired lift and control during the ascent and descent phases. Therefore, the burner efficiency of a hot air balloon decreases approximately 4% for each 1,000 feet above MSL. 6854. Below pressure height, each 50 F of positive superheat amounts to approximately A. 1% of net lift. B. 1% of static lift. C. 2% of gross lift. The correct answer is B. Below pressure height, each 50 degrees Fahrenheit of positive superheat amounts to approximately 1% of static lift. In hot air ballooning, superheat refers to the temperature of the air inside the envelope being higher than the ambient air temperature. Positive superheat occurs when the air inside the envelope is hotter than the surrounding air. The lift generated by a hot air balloon is primarily determined by the temperature difference between the air inside the envelope and the ambient air. This temperature difference creates a pressure differential, with lower pressure inside the envelope compared to the surrounding air, resulting in buoyancy and lift. The amount of lift generated by positive superheat is approximately 1% of the static lift for every 50 degrees Fahrenheit increase in temperature above ambient. Static lift refers to the total lift generated by the balloon at a specific altitude and temperature, including the weight of the envelope, basket, payload, and any ballast or fuel. Therefore, each 50 degrees Fahrenheit of positive superheat amounts to approximately 1% of static lift. This means that as the air inside the envelope becomes hotter than the surrounding air, it contributes an additional 1% of lift per 50 degrees Fahrenheit increase in temperature, enhancing the overall buoyancy and lift of the balloon. 6855. The difference between the weight of the air being displaced and the weight of the lifting gas is A. Gross lift. B. Useful lift. C. Design lift. The correct answer is A. The difference between the weight of the air being displaced and the weight of the lifting gas is referred to as gross lift. In the context of lighter-than-air flight, such as in hot air ballooning or gas ballooning, the concept of lift is crucial. Lift is the force that opposes the weight of the balloon and enables it to ascend and float in the air. Gross lift is a term used to describe the total amount of lift generated by the balloon. It represents the difference between the weight of the air being displaced by the balloon, also known as the displaced air mass, and the weight of the lifting gas contained within the envelope. When a balloon is filled with a lifting gas, such as hot air or helium, it displaces a certain volume of air equal to its own weight. The displaced air mass, which has a weight equal to the weight of the balloon, exerts a downward force. The lifting gas, on the other hand, exerts an upward force due to its buoyancy. The gross lift is the net result of these two forces. It represents the total force that opposes the weight of the balloon and determines its ability to ascend and stay aloft. Gross lift is influenced by factors such as the volume of the balloon, the density of the lifting gas, and the density of the surrounding air. In summary, the difference between the weight of the air being displaced and the weight of the lifting gas is referred to as gross lift. It represents the total lift generated by the balloon and is essential for maintaining buoyancy and flight. 6638. An airship with a small fineness ratio has a hull form that will introduce A. Greater nose pressures. B. Lower pressure variations from nose to tail. C. More frictional drag due to the plump shape of the hull. The correct answer is C. An airship with a small fineness ratio has a hull form that will introduce more frictional drag due to the plump shape of the hull. The fineness ratio of an airship is the ratio of its length to its maximum diameter. A small fineness ratio indicates a relatively shorter and plumper hull compared to its diameter. This plump shape results in a larger frontal area, which increases the surface exposed to the airflow. As the airship moves through the air, it encounters resistance from the surrounding air molecules. This resistance is known as drag. Frictional drag is one of the components of total drag and is primarily caused by the shear forces between the air and the surface of the airship. The plump shape of an airship with a small fineness ratio increases the frictional drag because there is more surface area in contact with the airflow. The larger surface area creates more skin friction, which contributes to the overall drag of the airship. In contrast, a sleeker airship with a larger fineness ratio would have a more streamlined shape with reduced surface area exposed to the airflow. This would result in lower frictional drag. Therefore, an airship with a small fineness ratio introduces more frictional drag due to the plump shape of its hull. 6634. An airship will float in the air when buoyant force A equals horizontal equilibrium existing between propeller thrust and airship drag. B equals the difference between airship weight and the weight of the volume of air being displaced. C is less than the difference between airship weight and the weight of the air volume being displaced. The correct answer is B. An airship will float in the air when the buoyant force equals the difference between the airship's weight and the weight of the volume of air being displaced. When an airship is in flight, it generates buoyant force, which is the upward force exerted on the airship due to the displacement of air. This buoyant force counteracts the weight of the airship, allowing it to float and maintain equilibrium in the air. The buoyant force is directly related to the weight of the volume of air being displaced by the airship. According to Archimedes' principle, the buoyant force is equal to the weight of the fluid displaced by an object. In the case of an airship, the fluid is the surrounding air. For the airship to float, the buoyant force must be equal to the difference between the airship's weight and the weight of the volume of air being displaced. This means that the buoyant force must be sufficient to counteract the weight of the airship, allowing it to remain suspended in the air. If the buoyant force is less than the difference between the airship's weight and the weight of the displaced air, the airship would be heavier than the buoyant force and would not float. Similarly, if the buoyant force exceeds this difference, the airship would be lighter than the buoyant force and would rise in the air. Therefore, an airship will float in the air when the buoyant force equals the difference between the airship's weight and the weight of the volume of air being displaced.